Prime factorization is often used in mathematics to help us break down problems into something a lot simpler. Let's have a look at why we do it via an example. In this case here we're being asked to divide 360 by 18 using prime factors. Now we could use a calculator or we could use pen and paper, but let's see how prime factorization actually breaks this problem down into something that's easier for us to handle. To break down a number into its prime factors, what we have to do is ask ourselves, what's the smallest factor which is prime? And that number is 2. So what we're going to do is split up 360 by dividing it by 2. And we can see here in our diagram that 2 goes into 360 180 times. What we're doing here is using a factor tree to split 360 into its prime factors. Now the red number 2 is a prime factor, and that's the end of that branch. The next thing to do is to look at the number 180 and repeat the process. So we ask ourselves, what's the smallest prime number that goes into 180? And that number's 2. 2 goes into 180 90 times, so we again branch off our tree from 180 into 2 and 90. 2's the end of that branch, and we now repeat the process and say, what's the smallest prime number that goes into 90? That number is 2. So again we split 90 into 2 parts, and we split it into 45 and 2 because 2 goes into 90 45 times. Now with 45, the smallest prime number that goes into that isn't 2, but it's 3. So 3 goes into 45 15 times. 3 is the end of that branch. We now go to 15. 3 is the smallest prime number that goes into 15, and it goes into it 5 times. Now because 5's a prime number as well, that means we've finished our factor tree. Now we use this diagram to break down 360 into its prime factors. Notice that the end of each branch of our tree has been highlighted in red, blue or brown. They form all the prime factors of 360, and we write that as a product. It would be wise to pause here and check to see that you agree that that product does equal 360. We can also express 360 as a product of primes where we've written an index form. You'll notice that 2 is being multiplied 3 times by itself, 3 by itself twice, and then of course 5 is by itself just the once, so we leave that as multiplied by 5. Now let's look at the other number in our division problem, and that's 18. The smallest prime number that goes into 18 is also 2, and that goes into 18 9 times. We then look at the number 9 and say the smallest prime number that goes into 9 is 3. It goes into 9 3 times, and because both of those 3's are prime, we've finished our factor tree. So we can now express 18 as a product of its prime numbers, and that product is 2 multiplied by 3 because they're the end of each branch of our factor tree. We can also simplify that by expressing 18 as 2 multiplied by 3 squared because 3 is being multiplied by itself twice. So there's our two numbers in our division problem written as a product of primes. Let's see how that actually helps us solve the problem. What we'll do now is express this division again, but as a product of the primes for 360 and 18. We can see here in the division that we've got common values between top and bottom line. In fact, we'll do some cancelling here and say that we've got 1 2 on the top that's common with another 2 on the bottom, and we've got 2 3's on the top which are common with 2 3's on the bottom. So that leaves us with 2 multiplied by 2 multiplied by 5, and that of course comes to 20. So prime factorization here enabled us to break down the numbers 360 and 18 into smaller forms, which helped us with the division problem.